All right, so we're doing transformations of sinusoidal functions here. And you'll recognize some of the same letters in our transformation function, A, K, D, and C. They do the same things, but we just have different names for them. So A is still the vertical stretch or compression, but when you stretch or compress a sinusoidal function vertically, that is its amplitude. K is the horizontal stretch or compression, just like normal. But when you stretch or compress a sinusoidal function, what you're doing is changing the period. So the period is 360, what it normally is, divided by your horizontal stretch or compression. Okay, you notice it's not the reciprocal of K, it's just K, right? So you're multiplying by the reciprocal or dividing by K. D is horizontal translation, but we call it a phase shift. But it means the same thing. And then C is a vertical translation, up or down, but this will be your equation of axis. Because normally, without any transformations, the parent function has the equation of axis as 0. So if I add anything or subtract anything from 0, it's just whatever that number is. So C is the equation of axis. So let's jump into an example here. We're graphing sine. We have a vertical stretch of 2. There's a horizontal compression by a factor of 1 over 2, because remember, we take the reciprocal of K. And we're moving up 1. So I start with the equation of axis. So I'm going to do 2 boxes as 1, just so I have a little more space here. So that's 1. So the equation of axis is along the equation, or the line y equals 1. Now, the amplitude is 2 because the A value is 2. So that means I'm going to go up 2 spots. Again, I'm doing every 2 spots is 1. So be 2, 3, 0, -1, -2, -3. So I know that my amplitude is 3. It goes up to 3. And my maximum point would be 3, and my lowest point would be -1. Since the K value is 2, I need to now figure out what my period is. So the period is 360 divided by the K value, which is 2. That makes 180. So there's no scale here, which means I can make up the scale as I like. So I'm just going to spread it out. I'm going to make every 4 boxes something significant. So if that's 180, half of that is 90. 45, 135. And so remember, you take your period and divide it by 4, and that will be your sections or your quarters of your period. Now, I have to remember what sine looks like. So sine x looks like this. Right. starts at the equation of axis, goes up to the maximum point and back down again. So because I remember that, I'm going to start at the equation of axis. In the first quarter, I'm going to go up to the maximum point. Next quarter, back down to the equation of axis. Okay, not the x-axis, but the equation of axis. And then the next quarter to the minimum point, so that'd be -1. And then back up to the equation of axis. So this is our graph. That's one cycle of it. It does continue on in either direction, both left and right, but normally when we graph, we just graph one cycle. Okay, so amplitude. This isn't the period, but it tells us that the period is 360 divided by 2. And this is my equation of axis. So that's it. We've graphed it. Okay, so in the next example, we want to make sure that we remember to factor out the k value. Not sure why it does that. Start over. So if I factor out 0.5, get x plus 90. Sorry. X plus 90. So I can see here that my amplitude is 3. I don't know why it's doing this. And it's negative, which means there's going to be a reflection. So the period is 360 divided by 0.5. So that's the same as multiplying by 2, so 720. And we have a translation of 90 degrees to the left, because we're adding 90. So it goes in the opposite direction, right? In negative direction. So you could use the mapping rule for this, and I will show you that. I don't think it's the easier way to go, but it's up to you. So in this case, my equation of axis is 0, because I'm not adding or subtracting anything. So it's still the x-axis. My amplitude is 3, so I know the highest point is going to be 3. And the lowest point is going to be -3. We've reflected, but we'll talk about that in a second. The period is 720, but I've also moved 90 degrees to the left. So I'm not starting at 0, I'd be starting at -90. So essentially what we're doing here is, I'm going to erase this in a second, but we're saying that that's the highest and lowest point. This would be my left boundary, because we moved 90 degrees to the left. And now if I continue 720 degrees this way, where would I end up? Well, I'm not going to end up at 720. That would be if I didn't do any horizontal translations, if I didn't have a phase shift of 90 degrees to the left. So because of that, I'm not going to end at 720, I'm going to end at 630. So my function is going to exist, or one cycle of it anyway, is going to exist within this box. So what I like to do is figure out where my box is. What are the boundaries of my one cycle of this function? So again, we know we're going up to 3 and down to -3. The left-hand side will be at -90. The right-hand side will be at 630, because that's 720 degrees between -90 and 630. Now that I've thought about all that stuff, I know that it's sine, so it's going to start at the equation of axis. And then in the next quarter, it's going to go down because it's been reflected. Instead of going up, down, and up again, it's going to go down, up, and down. So now I got to figure out what that quarter is. So if I take 720 and divide it by 4, then I can figure out what those 4 sections are. So it's 180. So every 180 degrees, something's going to happen. So this is like my sections or quarters. These aren't official terms, but these are just names that I use of the period. Sorry. Can't even erase it. I don't know what's going on. Okay, whatever. Ignore it. Okay, so sections of the period. So every 180 degrees, something is happening. So from -90 to 90 would be my first quarter, because that's 180 degrees apart. Normally I'd go up, but because it's reflected, I'm going to go down to the minimum point. Then I'm going to go 180 degrees later, back to the equation of axis. So 180 degrees, or 4 boxes in this case, to my maximum point, and then to the minimum point. So this would be one cycle. That was pretty terrible. One cycle of that function. Okay, so just remember that you don't have to do the mapping rule. You can do what I did over there. But I'm going to show you the mapping rule for this one, and then you can decide what you want to do. So the mapping rule is the same thing that we've done before. It's whatever's happening to x and whatever's happening to y. So the k value is 3. So in the mapping rule, it's going to be 1 over 3. But nothing else is happening to x. Not adding or subtracting anything, so it's just 1 over 3x. And then for y, it would be -2y minus 1. Now, I need to put in points from the parent function. So because it's cos, I need to remember what cos looks like. And cos looks like this. So you're going to have to remember the points on cos x. 0, 1. Oops. And we have 90, 0, 180, -1, 270, and 361. So if you remember those points or can redraw what cos x looks like, which you should be able to, you need to then take those points and put it through the mapping rule. So 0, 1, 90, 0, 270, 0, and 361. And you're going to transform these points. So 0, then -3, 30, -1, 60, let's positive 2, 1, 90, -1, and 120, -3. Okay, so those are the coordinates of your new graph. So there are no, there's no scale here. Normally there would be a scale, but we're going to make our own scale then. So I need to do 0, 30, 60, 90, and 120. I'm making my own scale, so I'm going to spread it out to make it easier for me to graph. So again, I'm just going to do every 4 boxes, just like I did before. And every 2 boxes going up. Actually, I'm going to go off the graph then. So I'll do every 1 box here. So 0, -3. 30, -1. 60, 1, 90, -1, -3. And we have our cosine function. It's a little skinny, but that's the way it is. If I stretched it out a little bit, you would see it a little better. It looked like something like this, but it would have gone off the graph, so I didn't want to do that. But that's okay. That's how you use the mapping rule. Now, I don't think it's easier to use the mapping rule, but I'll leave it up to you, whichever one you like better. If you were to use the mapping rule, you just have to remember the values of cos x and the values of sine x, because that's what will go in here. So that's going to change whether you're doing sine or cos. Okay.